Hi everyone, today we are finally going to be talking about solving quadratic equations, and we're going to discuss several methods of doing so that put all of the things that we've been doing over the last couple of lessons together. So we're going to start by solving using square roots, and we would use this technique whenever the bx term is missing. Remember that our standard form of a quadratic is ax squared plus bx plus c, so we're talking that middle term. So let's notice that this first one has an x squared and a constant, but no b times x term. It is set up the way that we want to have it for solving with square roots, with the squared term on one side and the constant on the other. And so in order to undo squaring x, we want to take the square root of x. However, if we do that to one side of the equation, just like when we add, subtract, multiply, or divide, we have to do it to the other side of the equation as well. So we're going to say square root of 81. We also have to realize that there's something a little special when we take the square root of something that is already squared. We don't know if that thing that is being squared was two positives multiplied together or two negatives multiplied together. And so we need to take into account both cases, a positive and a negative. So in other words, x is equal to positive or negative 9. Because if you think about it, if you multiply negative 9 times negative 9, you also get a positive 81. So this is our solution, and this positive and negative thing will be the case every time that we use a square root in order to solve something. This next one has a little more to it, but we can still see that we have something squared on the left-hand side and a constant on the right. So I'm going to take the square root in order to solve, and again, remember my positive and negative. This time I'm going to end up with y minus 3 is equal to positive or negative 5. I need to continue solving though because I haven't actually solved for y yet, which means that I need to add 3 to both sides. And so I need to take into account two possibilities, that y is equal to 3 plus or minus 5. So if I think of the positive case, I have 3 plus 5, or y is equal to 8. If I think of the negative case, I have 3 minus 5, or y is equal to negative 2. Let's look at one more example. The first thing that I notice is that my constant isn't isolated, so I want to do that first. I'm going to take 31 and move it to the right by adding 31 to both sides, leaving me with 4x squared is equal to 80. Now, I can continue simplifying this. All the things that we can typically do with equations, add, subtract, multiply, and divide, still apply. So I can continue to solve for x by dividing by 4 on each side, leaving me with x squared is equal to 20. Now I want to go ahead and take the square root of both sides. I notice though that 20 is not a perfect square, so I'm going to use the technique for simplifying things under a square root that I learned previously, and I can break 20 into 4 and 5. 5 is a prime number, and you might recognize that 4 is a perfect square. So the square root of 20 could be rewritten as the square root of 4 times 5, but that 4 could be pulled out to the front as a 2 and then square root of 5. So let's go ahead and finalize our answer by saying that x is equal to positive or negative 2 square root of 5.